So now we discuss the change of bases, the general case, and we will express a linear transformation with respect to several bases. So consider a basis beta, v1, v2 until vn, as an alternative to the standard basis consisting of the standard unit vectors. So suppose tx equals a times x with respect to the standard basis. So the standard coordinates are used here. So this is a transformation from Rn to Rn. Well, starting off with an arbitrary vector in Rn, this vector can be expressed as a unique combination of v1, v2 until vn. c1, c2, and cn are the coordinates of this vector with respect to v1 to vn. Then we know that tx is ax is c times tv1 plus etc. cn tvn. Now the coordinates of x with respect to the new basis beta are c1, c2, etc. cn. And these coordinates are mapped onto the image t of x with respect to the new basis beta using a matrix B. And we've already seen that if we make a matrix in which we put the new basis elements v1 to vn as columns, then we can go back from the coordinates with respect to beta to the standard coordinates, just multiplying from the left with s. So we get v1 until vn times the coordinates c1, c2, cn equals the natural coordinates, or the standard coordinates of our vector x. Yeah, so actually we can do the same thing with the coordinates of tx with respect to the new basis beta. So if we multiply from the left with s, then we get t of x. Yeah, and the inverse, we know the inverse of s exists because we have n independent vectors, so we have a invertible matrix S. So now we have a commutative diagram. So if we would first apply S inverse to get x expressed as in terms of the new basis beta, then apply B, and then S again, we basically walk around and we get t of x. So actually the working of A is the same as the working of the matrix multiplication S times B times S minus 1, or the inverse of S. Which means that we also, if we are given a matrix A, we can calculate the matrix B as by S inverse times A times S. Well, the matrix B is called the matrix of T with respect to the basis beta. Well, you may question why we would pick a new matrix B or define a new set of vectors v1, vn. Well, sometimes it's very instructive to see that this B can actually made very simple. I may take a diagonal form. And we've already seen that actually the matrix B is no more than expressing what happens to the basis elements v1 with respect to the same basis beta until tvn with respect to beta. Well, recall we had such an idea since the matrix A was basically the mapped standard vector. So A, the matrix A, consists of TE1, etc. TEN. And these matrices for the mapping T, for the linear transformation T, are different, and in general, and they they are based on the use of a different basis. So the same T and different matrices for T with respect to different bases.